All right. So, if I want to find vector u plus v, what should I find first? Or what two things should I find first? Of both, I should find the component form of u and the component form of v. Okay? So, if I'm going to go with u here, u is going to be the magnitude of u, which was 35, times the cosine of u's direction angle, which is 25 degrees, and then the magnitude of u times the sine of the direction angle. Gets me that. Agree. Okay. Then I need to find the component form of v, which is going to be the magnitude of v times v's direction angle cosigned, and magnitude times the sine of v's direction angle. Yes? Okay. And then u plus v is going to be those two added together. Well, u is 31.72 and 14.79. V is negative 25 and 43.3. Okay. So that gives me vector, whoops, tap the brakes. That gives me vector u plus v here is the vector 6.72, comma, 58.09. Yes? Huh? The magnitude of that one then is going to be the square root of the x part squared plus the y part squared. So that's going to be 6.72 squared plus 58.09 squared, and then the square root of that, which is going to be the square root of 3,419.95. So the magnitude of u plus v is going to be 58.48. Agree with that? Okay. Then it asked us to find u plus v's direction angle. Well, I first need to ask myself, which quadrant is u plus v in? Which quadrant? Why quadrant 1, Sam? Positive, positive, so that's quadrant number 1. Okay? Which tells me that my reference angle is equal to my direction angle. Right? If it was in quadrant 2, I would subtract my reference angle from 180. If it was in quadrant 3, I'd add 180 to my reference angle. If it was in quadrant 4, I'd subtract my reference angle from 360. But in quadrant 1, they are one in the same. So my direction angle of u plus v is going to equal the inverse tangent of y divided by x and I would have to drop any and all negative signs, but because it's positive, I don't have to. Okay? So that gives me then my direction angle of u plus v is going to be 83.4008 degrees. Now, your answers might be just a little off. Okay? When I calculated mine, I calculated them leaving stuff on the calculator and using that all the way through. If you rounded way back at the start of when you found the component form of u and rounded to find the component form of v, that means then everything after that's going to be rounded and it's going to be off by just a little bit. Shouldn't be off by that much because we're not talking huge roundings. Should go. Okay? Questions on that one? Okay. So, now let's talk about forces acting upon an object. Okay? So let's get into some application type things. Okay? So if I have multiple forces that are acting on a single object, okay? Let's take, for instance, a basketball. Okay? It's got two forces acting upon it. Okay? What are the possible outcomes, regardless of what the size of the forces are, but just know that those two forces are coming from the bottom. What are my possible outcomes on that basketball?
I just have a question.
Yep.
Is this what we're supposed to do?
Writing in that big blank space. Yep. Yep. Okay. So what are my possible, which directions could that basketball go? So it could go this way, right? Okay. Or you were also saying, Ed, that it could go that way? Okay. Could it go straight up? Could it go straight down? Why not?
We're probably assuming that the forces that are getting involved in log are stronger than the gravity that's pulling on us.
Well, let's say we're in a vacuum. Let's even go even farther and say we're in weightlessness. You know what I mean? We're quote unquote weightless.
So then it just like go up, and then it just like keep going up, I guess.
Okay.
The length of the vectors are the same.
Okay.
Two forces are different.
Okay, so two forces are different. What about a negative force? If I want this ball to go down, I'd have to, one of those forces is going to have to be negative, right? But then the arrow would have to be facing the other way, which we learned yesterday, yeah. So this ball has to go up in one of those three directions. Okay? Right? Great explanations of that. Good job. Okay? All right? So, we're going to call that result, what the basketball does, we're going to call it something along the lines of the result or the resultant force. Okay? Those are the two kind of names that we're going to go with. But the result here, actually we can put it in this one. The result is going to be the sum of all of the forces that are acting upon that object. Okay. So the result, what that object's going to do is going to depend on everything that's acting upon it. Okay? And so the sum of all of those forces is what's going to move that basketball. Okay. So, let's dive right into a problem, okay, at the bottom of that page. 3 forces with a magnitude of 70 pounds, 40 pounds, and 60 pounds act on an object at angles of negative 30 degrees, 45 degrees, and 135 degrees, respectively. Now, I'm going to pause right here for a minute, drop back into a little English language type thing. What does respectively mean in that sentence? So the order that the force is in is the same order that the angles go on. Okay, right? So 70 is paired with negative 30 degrees, 40 is paired with 45 degrees, and 60 is paired with 135 degrees. Okay? So that's what that respectively. Sometimes people forget what that is, or they've never seen it, or, so it happens. Okay? Then it says, find the magnitude and the direction of the result of these forces. Okay? Well, the result is going to be what? The sum of all the forces, right? So we should probably find all the forces, find their component forms, and then do what with those? Add them all together. Okay? Right? From that, then, that's going to give us the component form of a result. We can find the magnitude of it, which is what we have to do, and we can find its direction angle. Yeah? Think we can do that in 13 minutes? I think we can. Go for it. You start. Let's call our forces A, B, and C. So I want to show on this problem, I want to show how I calculate it. And I calculate it, and I use an Inspire calculator to do it. So I'm going to be flopping back and forth between the Inspire and the Smartboard here. Okay. So the first one, so vector A is going to be 7d times the cosine of negative 30 degrees and 70 times the sine of negative 30 degrees. And that is going to end up giving me 35 square roots of 3 and negative 35 here. Oops, that should be negative 35. Negative 30. Okay. And then B is going to give me 40 times the cosine of 45 degrees and 40 times the sine of 45 degrees. And that's going to give me 20 times the square root of 2 for both. Now, you might have rounded those 4 to be like this one would have been 60.6218-ish. And this one would have been 28.2843. And that's fine. Okay? The more decimal places that you round to, the better in the early stages. When it gets to the end, if you want to round to tenths or hundredths or something like that, that's fine. But the more that you leave on your calculator or the likewise, that's better. Okay? C here now. Part C, I'll show you how I do it on the calculator. Okay? So this is going to be 60 cosine of 135 degrees and 60 times the sine of 135 degrees. So when I go to the calculator, I did the cosine one already. So I type in 60 times the cosine of 135 degrees, and then I store it on my calculator, because then it's stored as a letter on my calculator. Okay? And so my next one would be 60 times the sine. Oops, that's inverse sign. I want to go positive sign. Trig. Back. No, it's going to be all goofy. Times the sine of 135 degrees. And I want to store that as F then. Okay? So that gives me negative 30 times the square root of 2, comma 30 times the square root of 2, or that is negative 42.4264. Okay? Then my resultant vector is going to be the sum of A, B, and C. So I'm going to add all of those up. Now, on my graphing calculator, on my Inspire, I can go A plus C plus E, and I can store that as X. And then I have that X part of my resultant vector right there for me. So that's going to be actually, we don't need this. We just need the magnitude. So that's going to be 46.4796. And then the Y part is going to be B plus D plus F. And I'm going to store that as Y. And that's going to be 35.7107. Okay. Now from that, now we got to find the magnitude. So the magnitude is going to be 46.4796 squared plus 35.7107 squared, which is going to be 58.6141 pounds. There was a label in this problem, so there's going to be a label on our answer. On my calculator to get that, I just do the square root of x squared plus y squared. Cool calculator, using how to, or knowing how to use it. Okay? All right. Then I need to find my direction angle of that resultant force. So the resultant force is going to be in which quadrant? Quadrant 1. So my reference angle is going to be my direction angle. Okay? So my theta of my result is going to be the inverse tangent of 35.7107 divided by 46.4796. When I do that on the calculator, that then is going to be So I go trig inverse tangent of y divided by x. If one of them were negative, to drop the negative sign, then I would just put a negative y or negative x in there. And I get that. But what's wrong with that? That's the in radians, right? So I got to convert it. So I got to multiply that by 180 and divide it by pi, which gives me 37.5354 degrees. Okay? Again, don't forget, you have a formative that you need to do online this week